Right, Phil, how long have we got?
We have got, as long as you want, probably about an hour, a little bit more if you get into detail or etc. If anyone's got any, they want to ask a question, if they come off mute, ask the question and come back off mute, that'll be useful.
Yeah. Okay, cool. Hi everyone. Yeah, you were not in the same room. I'd rather stand at the front of a room and be much more animated than sit behind a desktop. But then I'm thinking back, I've already done this for the last 20 years, so I should be okay at doing it at the moment. Just as an intro, in terms of my background, been around a while. Started out in the IT industry, then swapped over to telecoms, then went back to IT, then jumped into telecoms again. So pretty much in the corporate world up through, dare I say it, 93. Then I set up my own software company and made a nice little sum of money leading up to year 2000, swapping out legacy email systems. Since 2000, decided to get back into telecoms, initially bidding for a 3G license for what was NTL at the time before it became Virgin, but jumped really into the telecoms infrastructure market. So I've run a couple of largish organizations across Europe doing RF engineering, doing tower builds, mobile phone masts, microwave links, fiber, all that type of stuff. Got fed up with NASDAQ companies and their short-termism, so I've been independent since 2004 and focused in 3 areas really. One is still telecoms, so I got pulled in by a VC to go and run a handset company for 3 or 4 years, which meant spending a lot of the time in China. The main thrust is I've assisted organizations both in winning spectrum and also have won my own spectrum and sold it on at auction. Towers, so even today, so that's nearly like 20 years worth of working with towers. My engagement is very much at a high level of due diligence oversight on behalf of investment organizations looking to acquire tower portfolios and tower assets. Obviously 4G came along, been involved with that. I've been involved with 5G since approximately, just gonna think, yeah, 2014 now. I was a non-exec at a techco doing some very clever stuff with smart antennas, beamforming, beam steering. They were based up in Winchester, and I got pulled in to help commercialize what was then a set of military technologies, and we were reasonably successful with it. We did some good things. And more recently then with fiber. And on the fiber side, I've been working with a couple of fiber cos. I am working with a couple of fiber cos, one building fiber to the premise. So that's very much the residential connectivity. So it's 1 gigabit symmetric, slightly different format. It's presented as Ethernet back to an access node. And then from the access node, it's straightforward managed service backhaul into a open wholesale access platform, so any ISP can plug themselves in the back of. And the other guys are what's called a deep fiber or fiber spine provider, so they actually provide the backbone connectivity for some councils. They're doing the same with business parks. We've also been working with mobile operators on fiber backhaul for towers. On the basis that every single tower in this country is going to need fiber pretty damn quick if we're going to have decent 4G and some very good 5G. Yeah. So that's my background. So I've been independent since 2004. I tend to work with sort of multiple organizations. I spend a lot of time with SME startups. I spend a lot of time working with CEOs of some clever companies, 1, 2, 3 different types of companies doing drones. One company that has an AI system that allows you to take a LiDAR image of a bunch of trees. So you fly an airplane 10 kilometers along a power line, LiDAR the trees, and stick it in the back end of the database, and at the other end it will tell you exactly how many trees, which trees are where, the type of tree, the age of the tree, the growth rate of the tree. It's used by the power distribution companies to actually do forecasting on when they need to go out and get the chainsaws out and trim the trees back. Likewise, I'm doing some helping the CEO of another company, similar type of capability, but this takes either video or standard photos. So you can walk up to a mobile phone tower, give instructions to a person with a mobile phone to take half a dozen pictures of the tower. You just upload those through the cloud into the AI, and at the back end then will come a report, and the AI will figure out the type of tower, the height of the tower, what type of steel is used on it, the type of antennas, and other bits and pieces. So some really neat, clever stuff. But anyhow, we're going to go and talk about 5G and specific topics, what it is, some of the verticals and use cases, on the basis that it's not going to be just you and I using a 5G handset. The timeline between now and 2025, and I'll explain why 2025 is important, and how it sits within the scheme of things. Areas of connectivity, so that's going to be for the techies around, that will be the types of antennas, why those types of antennas, where they're being installed, how many of them, etc. Then we're going to go slightly sideways and look at some of the application areas, and then finish up with a catch up on DCMS, where it's at with 5G test beds, and how you, if you wish to, wanted to engage with those 5G test beds and what they're doing. So that's what we're going to get onto. So we kick off. What is 5G? The vision. It's very much about. Originally, it was about being a step change, but I think people have realised that was just one step too far. So it's an evolution. So if you look at the picture there, if we could achieve, say, a quarter to a third or even a half of what's shown on that picture, in other words, connecting all those different devices together, the sensors, cars, vehicles, buildings, people, etc., and actually bring that all together underneath a single platform, then 5G will be a success. And that is really what we're looking to do with the capability. So 5G as it exists today, in other words, you go buy a handset and your downloads are a bit faster. That's not what 5G is about. So 5G is about a whole bunch more things, not just the handsets, not just the radios. It's also about the clever stuff that happens back in the core of the network, and things yet to happen. So there's a lot of stuff that is not there today, but will come there in the future. But on terms of performance, the aim originally was to deliver fiber-like performance without the wires. Theoretically, will it do it? Yes, absolutely. I've got a 5G handset. According to the specs, if you take it into the lab, it will do 1.2 gigabits on 4G, it will do 2.1 gigabits on 5G. Going into London on the train, as you get just close to Clapham Junction, the 5G symbol comes up. I can sit inside a South Western Railways train now, and I can do a speed test and stream videos, and I should be able to actually stream 8K video, because I can get 80 megabits down inside the train. People keep reminding me I'm the only one with a 5G handset doing that, so it's not going to get any better shortly, because everyone else is going to get a 5G handset as well. But there is another way of looking at it, and that is that you and I, or a device, or a bunch of devices, or a million devices, get the connectivity experience they think they need or want at a given point in time. So in other words, if you're just walking along, you want to quickly browse something, if it's fast, then great. If you want to stream a 4K or an 8K video and it works, then even better. Now, so this is all about trying to configure the network to do things for you, as opposed to 4G, where you're just purely dependent on the network. That's it, full stop. So moving on, what is it? What are the 3 or 4 things that really make it work today? There are some wonderful spider diagrams about all the features and functions and the performance characteristics about it. But if you look on the left-hand side, there are 3 things. Enhanced mobile broadband, in other words, gigabit per second capacity. And there are two aspects to that. One is the peak capacity rates you could theoretically achieve, assuming you are say 50 meters from a base station, you had all the spectrum you need, and you don't care about the fact that your battery is going to die after 30 minutes, as opposed to lasting all day. But peak rates of way into the gigabits. Average speeds, obviously, will be a lot less than that. So if you put 100 users onto a 5G base station, yeah, for sure, you're going to get a lot less individual capacity coming out of that. Massive IoT. Massive IoT is about how can you efficiently connect millions of devices. So if you go back 6 or 7 years when 4G really hit in the US, all 3 primary or 4 primary network operators, pretty much their networks died overnight. And they died not because of all the data that was going to get sucked down by these new 4G devices. They died because of the signaling overhead. So this was literally the overhead of messaging back through the networks. So if you took a sort of simple homepage on a decent website, and if there's 100 different elements on that, that's 100 individual requests that go back through the network. Each request has to be encapsulated, address translation, encrypted, etc., etc. So you can see that the overhead would actually build up even before you get the page displayed. So massive IoT learned from that experience. So it puts in place the protocols and the scheduling mechanisms and the resource management such you can have millions of connected devices without actually crippling the network itself. The third one on the bottom right, critical communications, or as it's known, ultra reliable, high availability, low latency. 2 aspects there. Ultra reliable in terms of being able to prioritize the traffic flows. So if you've got 5 different types of traffic going across it, and one of those is super sensitive, has to be prioritized over the others, then you can do that. So by prioritizing, you are increasing the reliability. You always have to remember one thing though, this is radio, and radios are not as deterministic as you'd like them to be. It's not like having a piece of Cat5 or Cat6 or a piece of fiber. So wireless will always have an element of uncertainty within it, but you can actually drive towards something that's more reliable. Low latency, yeah, we all understand latency, ping times and all the rest of it. The intent with 5G is to get below 10 milliseconds. So if you look at the average fiber to the home connection at the moment, it's going to be somewhere around to 8 or 9 milliseconds latency. The aim with 5G is to get below 10 milliseconds. It could potentially get closer to 1 millisecond, but the only way that's going to really work is with something like edge computing, where you stick all the compute power at the base station so you don't have to transit back through the network. As soon as you stick a few hundred kilometers of fiber in the way, of course, you're always going to get latency figures up into the way up into the milliseconds. Why do you need that low latency? There are 3 or 4 immediate applications, one of which is AR/VR, so virtual reality. Without that low latency connection, pretty much most people will end up getting seasick within sort of 20-30 minutes of putting a headset on. For audio, if you were to replace the analog audio systems that are used in TV and film production today and all the feedback systems there with digital, most actors or actresses would not be able to work with them because the latency on existing digital systems is very high. So with 5G, if you can drop that latency down to say 1 or 2 milliseconds, you can start doing some clever things in the broadcast area. There are bits and pieces like robotics and so on where you might want to go down into low latency. There are other areas where connected vehicles or autonomous vehicles, we'll come back to that later in the evening. So if we move on to the next one. Sorry about that, I was just getting a bit of refreshment. And on the next one, there is a distinction between what makes up a 4G network and what makes up a 5G network. without going into all the detail, if you look at the top of the screen there, the 4G network can be broken down into 4 bits. On the right-hand side, the data centers, a core network, then transiting over to an access network, in other words, the backhaul and frontal out to the towers, and then the radio network itself out to the handsets and devices. With 5G, the intent is to actually get rid of those distinct boxes and have a 5G network that extends from what is called the UE, or the user device, on the left, all the way back into the network, at which point you hit the data center and then you hit the internet. So it flattens everything. It gets rid of the demarcation points, such that if you can think about it, rather than having three different bits of access network and all of the complexity of that, 5G attempts to actually simplify some of the complexity, simplify the interconnectivity, and linearize it back into the network. If you start doing those types of things, then it makes life a lot easier.
Peter, quick question. Does that mean there's less need for cables in the ground? Once we've got this 5G network in place, it gives us a bit more. Is that one of the big benefits, or?
Not so much. It's more question, less boxes.
Okay.
So for instance, if you look at a base station, 4G base station today, at the back end of that, you've got a box to do switching, routing, another box to do, literally, not quite literally, but box to do address translation, encapsulation. You need to do encryption. Now, if you've got 2G, 3G, and 4G in the same base station, then you have to think about how you encapsulate the 2G underneath 4G. 3G can't be encapsulated because it's got circuit switch voice in it. If you then layer 5G on top of that, the existing 4G architecture becomes complex, but also extremely expensive. So the aim is being to simplify all of that down.
Peter, can I ask a question? Does that also partly explain why there is a particularly profound security risk in the Huawei conversations, because the network supply is going right back into the backbone nearly?
Yes. Well, okay, I'm not the security guy, but yes and no. Yes, on the basis that the 5G network exposes a lot more of the core to the outside world. So on a 4G network, you've got less exposed to the outside world. So if you look at 4G from the data center out through to the base station, that's traditionally been a very trusted environment. It becomes untrusted when you go from the base station out to the device itself. Yeah, for sure. On 5G, it becomes less secure on the basis that your trusted bit is the data center bit on the right-hand side. Then on the 5G network side, you go through a variation of both trusted and untrusted environments. And you'll have a lot more things that are exposed and a lot more points that are exposed as well. So yeah, is that a Huawei problem? Not so sure. It's if they're building things to the same 3GPP specifications, the same boxes, connectivity, and the rest of it, it ought to be true across all the vendors. So there are some specifics with regards to Huawei ZTE. We seem to want to trust Ericsson and Nokia and Samsung a lot more than we do Huawei and ZTE. But the one very specific thing, and this is where the Cybersecurity Center had a problem, and does have a problem. If you wished to do something, i.e. similar to lawful intercept or anything like that, you'd rather have a conversation with Nokia or Ericsson than having a conversation with Huawei. So if you have a conversation with Huawei about this is what GCHQ wants to use to actually plug into your box so we can do intercept, you can pretty much reckon that that's going to get go through Huawei and out the other side to an agency. You don't really want to have that information. So there's an element of trust there that doesn't exist with Huawei. Let me put it that way. Okay, so without laboring too much on sort of the difference between 4G and 5G, on the bottom diagram, you could spend a whole day going through the different ways you can build a 5G network, the types of options that are available, things such as what they call disaggregated RAN, where you split off the radios into different paths, different types, treat them differently, etc., etc. So it's not a simple topic. It is actually quite a complex topic. So it's actually quite interesting to see that so many countries and so many operators have got 5G up and running as quick as they have, given the complexity there. So anything else I'm going to say on that? Not at the moment. Let's just move on. Two things that I guess everyone really needs to pick up on with 5G. So the 5G that you and I see on the web, bump into in the street, at the moment is all about 5G in the consumer. For sure, there will be some interesting things happening in that market, other than just faster broadband, but they're not the real interesting things. So 2 years back, I had the opportunity to sit down and spend 4 months on behalf of the Digital Catapult to actually go build their 5G commercial strategy and value proposition. And at the time, I was focusing on manufacturing, immersive stroke creative, the transport sector, and also the health sector. But it was an eye-opener in terms of what you could use 5G for. So if you look at the slide in front of you, I've sort of highlighted sort of 10 specific use cases for 5G. There's 24 on the top screen. There's another 8 on the bottom screen. Out of the total that I could figure with both the help of Ericsson and a couple of other people, we came up with about 241 individual areas where potentially you could use 5G. That doesn't say you would have to use 5G. But out of that, I've simplified them back to 24, but there's only about 8 that are really relevant and consistent across the globe, across the country, and sit quite easily within sort of application areas that you and I could actually understand, see, and most probably would work with on a day-to-day basis. I'm going to leave this here because I've got a next slide which actually takes us into a much more better description. But basically, 5G from the consumer side, as far as the mobile operator is concerned, is a loss leader. So putting 5G out there, building a 5G network, getting 5G handsets out there, which are expensive, and then you and I, we might pay exactly the same that we were paying for 4G, or we might pay, say, 10 or 20% more because we're going to buy a more expensive handset for 5G. You can pretty much guarantee that an operator is not going to make any money out of selling 5G to you and I. Where they're going to make money, and not every operator will be able to get to this, is in all of the non-consumer applications. So that is the things such as smart manufacturing, energy, utilities, e-health, public safety, finance, etc., smart cities, etc., etc., etc. If you want to sort of have a peek at the bottom left of the screen, so 5G enabled industry digitization revenues for ICT. So this is a study that was done by Eddie Little, and basically it focuses on the transition from 2016 through to 2026, and it takes the sort of 240 odd use cases and shrinks them down to 8. So energy, utilities, manufacturing, public safety, healthcare, media and entertainment, public transport, automotive, and financial services. And here they've put a set of relevancy figures against them. In other words, they've figured out what they think the revenues could be and totted all that up. It comes to a number of about $1.2 trillion over that window as a potential revenues derived from digitization for ICT players. If you move to the right of the screen, and this is the more interesting one, the figures on the left there in green showing a 1.5% increase in operator service revenues 2016 through 2026. That's without 5G. If you add 5G in, the potential is you go from 1.5% growth to a 13.3% growth. And that is what's incentivizing not just the mobile operators, but a lot of other parts of the industry to actually go and say, yeah, 5G is actually quite interesting. How do we make money on this? And what we do. Top left of the screen is an update from Ericsson and AD Little, slightly different percentages, and this is the difference between early parts of 2018 moving through middle of 2019 as people better understand how 5G could be used as a connectivity system to deliver applications and so on. What that adds up to is a bunch of big numbers. What it most probably is more important is that where 5G is today, it will evolve over the next 5 to 10 years. Now, it will evolve to address potential applications certainly in the 8 areas I put up on the screen here. The types of things and specifics on that we can come back to a bit later. But if you take it for red now, most people can see the potential for doing this. There will be a challenge, and one of the biggest challenges will be the mobile operators themselves. Reason being is the mobile operators have spent the last 20 years flogging handsets and tariffs. So if you went up to a mobile operator today and say, excuse me, I want you to deliver 5G into my factory, I want you to hook up all these devices, I want you to deliver 3 different types of services and send me the bill at the end of the month. The standard response will be, how many handsets of that and what tariff do you want? Of course, that doesn't work. So there's a gap between where the operators are today and where they need to get to in the future. Either they become more educated, bring on staff who are able to actually sell in the public safety area, able to sell digital manufacturing, able to sell smart agriculture, and not only sell it, but market it, deliver it, implement it, send an invoice at the end of the month, or they have to engage with some of the big industry players, so the likes of IBM, Accenture, Capgemini, CGI, etc., etc. So that is a transition which is very much right at the very beginning. It's going to take a few years for that to come on.
Peter, quick question before you move on from this slide. The more efficient use of energy and utilities, what drives that? Just out of interest.
So this is about migrating the utility industry from being a static, we generate enough electricity or deliver enough electricity or enough gas or water at a given pressure to, but irrespective, we understand the demand, but we can only do this on a sort of large national type basis. So if you look at the electricity supply industry, we have the national grid, which is obviously the national distribution system, but underneath that there are 12, 13 called distribution network operators. Now, in the old days, all they did was just deliver electricity to our houses and to businesses. Nowadays, they are moving from a network operator to what's called a service operator. So legally now, they have to take into account that not only do they have the local distribution network, but there's also local generation. So all those houses with solar PV on, all those businesses that have PV on, the solar farms, so they're actually feeding in electricity over and above what these guys buy from the national grid. So that means they need to figure out how to manage that. And the only way they can start managing that is by connecting up all of the dumb assets that they've got. So that means they've got all those tiny little transformers that sit on poles, the little substation transformers, the big substations, etc. That none of that's really connected today.
Hello, Peter. It's Joe here. I used to work for SSE, one of the DNOs that you mentioned, and I was doing research projects on some of this stuff, albeit not with 5G. back in 2012 and 2013.
Mm-hmm.
The thing you're referring to is basically retrofitting smart IT, potentially now 5G enabled technology, onto substation equipment which has a stated lifetime of 40 years and is amortized over that period. So this is one of the things that's held back power distribution historically. But in terms of dealing with things like the generation coming into substations and so on, and previously all they knew was that certain cables were rated for a certain amount of voltage and current, they're having to do a thing called dynamic line rating now, where they can actually monitor it live and then accept or reject or do some sort of export control on people's wind farms and things like that, in order to get the maximum value out of the cables that they've put in already without doing cable reinforcement.
Yeah, it's an interesting, a very, very interesting area. And if you overlay that then with EVs and EV charging, so you've got high capacity EV charging at sort of central depots or bus stations, for instance, versus you and I all have EV charging points at home. And do you see that as a one-way or a two-way? So, for instance, the concept of using vehicle batteries to actually store energy, or vehicle batteries to actually deliver energy. So that effectively means that
there was always a lot of challenges around vehicle to grid, not least, protocols, various legal issues with somebody's car effectively being a mobile piece of generation anywhere on the network and things like that.
Yeah. But as I understand it, in terms of off-gem, then the driver is from a CO2 and energy efficiency basis, that CO2 reduction means we need to be more efficient, which means we have more renewables. Therefore, we need better management down to the micro level. And the only way you can do that is by connecting everything. I agree with you.
Back in 2012, they didn't even monitor the low voltage network. They didn't even have it on any of their GIS systems. And in a lot of cases, when DNOs had, acquired, mini DNOs and things like that, they'd had details of which house was on which phase on index cards and things like that, and they used to chuck them in the bin. So there's a lot of actually discovering things from first principles in various parts of the country with this, because they've simply not bothered to record it and manage it at that level up until very recently.
You're touching a sore point. I still have a 4-foot by 3-foot hole in my front garden with 3 bits of plastic barrier around, where SSE had to dig it up to actually fix a crack in the insulation on the 240 volts coming into the house.
It's happened to my next door neighbor in our street as well, and it's simply cables being overloaded, and then the water gets into the sheathing. You get steam, and the garden explodes. It's quite a thing to see. It does actually happen.
Well, what's on this one? What's coincidental? Sorry, guys, for actually going off track here, but the day before we had a power cut for 8 hours while they replaced 4 small transformers in the area. Of course, they replaced all of those. Then the next morning, just as the load kicks in, our connection to our house decides it's had enough.
Yeah, exactly.
So there's numerous things here. If you look at the manufacturing one, is not about hooking up robots. It's about other things. But let's come back to that separately. Thanks for the additional info there. And I'd love to be in the energy industry at the moment, because there's so many challenges, and they're difficult and they're long-term ones. But
one quick thing to say before we leave that point, just because it's something that we struggle with at the time. There was a lot of industrial IoT equipment for substations coming out of America. Companies like Cisco, who most people will be familiar with making network equipment, were also making grid routers and so on for substations. But in the US, the use of spectrum is completely different. And when you then try and rig up these devices in the UK, that spectrum was not available. So whether it was 5G or some other standard, something had to come along at some stage to unify this so that the kit that's been developed overseas could actually be used here.
Spectrum here in the UK has been a challenge for quite a while, possibly because of how the DNOs and that national grid work. Do you ever come across an organisation called JRC, Joint Radio Company?
Yes.
Yeah. So they've sat in a lot of workshops that I've driven on spectrum for utilities, and they always keep moaning about the fact that they don't have the piece of spectrum they want. And we've tried to help them out, but they're still in the wrong place in the room. They need to come onto the other side of the room to actually go figure what it is. But yeah, you're right. There's some real challenges there, and one of the biggest ones is resilience. So as soon as you go to a wireless connectivity versus wired, then your network's wide open, and it's vulnerable from many different aspects. But yeah, we'll come back to security in a minute. So let's just jump on from that one. So this is an old slide now. It's 2.5 years old. Manufacturing is not the only killer application. There are 2 or 3 other ones, but certainly across Europe, manufacturing has come forward as being one of the most probably the best uses of 5G away from you and I using our handsets in the street. And there are multiple reasons for that, and we will actually look at those. But in addition to manufacturing, there are 2 other areas. One is health, because of the need to connect lots of things for different reasons in different ways. And the other one is logistics / transport. So there are several applications. There won't be one dominant killer application, but certainly I'm not putting my money on autonomous vehicles. 5G and autonomous vehicles to me doesn't make sense. 5G and connected vehicles make sense. In other words, actually having cars or vehicles, bus vehicles in general, sending information out into the network, or the network sending information to the vehicles, or say, for instance, infrastructure around the vehicle, whether that be a building, traffic lights, and so on, sending information into the vehicle. That all to me makes sense. Having 10 cars all driving across an intersection, relying on 5G because they're all autonomous vehicles, doesn't make sense at all. I know there's masses of work going on in terms of vehicle avoidance systems and the algorithms that you need to ensure that if a car wants to pull out, it's not going to hit the other 2 cars that are adjacent to it, or the one coming the other way. To me, all of that needs proprietary, extremely fast and directly connected networks, and not something that relies on you going back into a data center somewhere. But that's just my take and my views on that. So I thought I'd just sort of show one example of how 5G fits in. And so this is on the manufacturer one. So picture on the left, we've got a factory. So we've got supply coming in, we've got vehicles in assembly line, we've got sensors, we've got robots, more sensors, some operations control, we've got inventory management, another forklift, and we've delivered out the other end. So effectively a linear fixed system, fixed in the sense that one thing can only happen after the other, and everything is managed in that way. To the right, 5G would introduce something called network slicing. So the concept is here today. You can actually demonstrate it today. In reality, it'll be a couple of years before it's fully available, certainly from a mobile operator. Network slicing basically says, okay, I've got 3 applications. So slice, in this case, slice A, slice B, and slice C. I want those 3 applications to run across the network in parallel. They're using the same physical network, but each application, i.e. each slice, has different characteristics. It will have different settings for speed, for latency, access, security, etc., etc. It will have, each one of those will have a different SLA in terms of what they have to deliver. So what you can then say is, right, given I've got multiple slices or applications running in parallel on the same physical infrastructure, I can now look at taking my linear serialized factory and actually making it happen in parallel. So all of a sudden now, I've got 3 different ways of actually changing my factory overnight. So I can actually take each one of those slices, reprogram that slice, deliver up a new slice. I've not changed the physical network. I've not done anything else to the factory, but I've now changed my industrial processes. And that's one of the things that is opening up digital manufacturing and 5G in the factory. This ability to actually say, well, great, yeah, last year we did this, but this year we want to do that. And no, we don't want to unplug everything. We don't want to move all the hard wiring. Yeah, what we want to be able to do is just move things around, still have them all connected, but we're going to change the whole set of processes that would happen in the factory. So here we've actually shown it with 2 different parts, 2 different factories with the interconnectivity, but each one of those processes is interlinked. And a good way of envisioning that is, say, for instance, if you took one of the case studies I looked at, which is Toyota. They're a manufacturing plant up in Cheshire. That, if you look at it in a whole life basis, so say, for instance, a customer in Germany orders a Toyota. That order goes into the local dealer. The dealer then feeds back into the European factory. In this case, it will be in Cheshire. From there, then things will go out in parallel to Japan, to local suppliers and the rest of it. All of that order, all of the different components and all the bits and pieces will end up in at the goods in part of that factory. But then hits the production line, everything's tagged, barcoded, tracked. It then results in the car being delivered at the other end of the factory. That car gets put in the field. It's got to get put in the field in the right place, such that when the transporter comes along, it's actually accessible without having to move all the other cars. It gets onto the transporter in a specific position on the transporter. Why? Because when that transporter gets all the way down to Southampton and gets to the docks, that transporter will be in a queue of other transporters. The car has to get on the ship in the right order and in the right place, such that when that ship docks up in Hamburg, the car is available to actually be driven off, put onto another transporter, and also then delivered out to the dealership. So you can see there's a big circle there. All of that is reasonably well connected today, but not as connected as people want to be, as efficient as people want in the future. Whether 5G is the technology to do that is still debatable, but certainly 5G could actually play an interesting part in that. In which case, we'll stop at that point. So thoughts, feedback on what you've heard so far?
Yeah, one thing, I mean, it's probably easier to visualize suppliers sending things in response to an order for a car, but again, I must say this was about 22 years ago. I worked for an exhaust manufacturer, one of my first contracts, and they actually had a manufacturing cell in the Ford Focus plant in Saarlouis, and they had to actually make the exhaust from raw materials 14 minutes before it had to be attached to the car. So the stuff already had to be on site, and they had to make it on demand, not just deliver it on demand. And I suspect Toyota's probably the same.
Yeah, absolutely. I had the luxury of visiting Rolls-Royce's factory in Chichester last summer, and had a tour around the factory, plus all the explanation of where different bits get built in the world, how they get all supplied. And interestingly, the factory in Chichester doesn't have a warehouse. Everything gets staged over in a set of warehouses just outside of Hastings. And it gets staged there, put in the right order, and then shipped across to Chichester. So, as you say, so it arrived just in time to actually be fitted onto that vehicle. And if you ever get the chance, it's actually well worth going to see, because Rolls-Royce only has a limited amount of automation, mainly in the paint shop area, and the rest of it's all done by hand. So you get to see on a close-up basis as to how this all works, plus all the vehicles, piloted vehicles that go around, which are driven by humans as opposed to robots at the moment. So, worth doing. Okay, any other questions, thoughts? No, good, okie dokie. Right, so what we're going to do next is just look a bit some of the technology. We're going to go into a bit more detail on this slicing. I'm going to spend some time on where we're at in the UK and then also globally with 5G in terms of the rollout and the deployment and the types of deployment that are happening. And can give you an updates on what's happening in the US, what's happening out in China, which is absolutely staggering. The latest figures that came out of China, I think it was yesterday evening, that even though China has just gone through a whole cycle of coronavirus and had a complete lockdown for 2 months, they're still talking about spending 14 billion on 5G this year, and that's just building out base stations. So yeah, I think we always need to bear in mind what's happening in different parts of the world. This was an interesting chart, and it was put together to show on the left-hand side the 3 primary characteristics of 5G. So mobile broadband, massive communication, and then the ultra-reliable low latency capability, and then map that across on the top line, which is human to human, human to machine, and machine to machine, and then slot in some of the applications. So if you look at it, if you go from, say, massive scale communication to the intersection with human to machine and drop down, you see healthcare monitoring. So that's an interesting segment, because that's basically all the wearables that you and I have today, plus all the wearables that we might have in the future. And how do we hook all those things up, whether via Bluetooth, IoT, or any other means, but on the assumption that 5G somewhere might actually sit together. I contributed to a report last year, which was 5G in pharmaceutical industry, which is quite interesting. Then how do you link those two things together? Pharmaceutical industry today spends billions on researching drugs because somebody has told them that they need to find a cure or fix for something. They then produce those drugs, they do all the trials, and then they mass produce it and they ship it out. Your GP, if you have to need that drug, does a prescription, and you get the drug. You may or may not take it as prescribed, etc., etc. But effectively, the pharma industry is completely disconnected from you and I, are the ones that actually have an infection or disease or whatever it may be.
Sorry to jump in. That's not actually true. It depends on the medicine that's being dispensed. With some of and I used to work for Walgreens. In some cases where the drugs are high value and it's critical that the patients take the drugs in order to maintain remission from their symptoms, then the pharma runs a patient support program, sometimes affiliated, sometimes directly, in order to make sure that they not only take the medication, but that they know how to take the medication. So it just depends on the circumstances.
You're absolutely right. I was just being more generalist there in terms of what I was saying, but yeah, apologies on that. But so the view in terms of the report there was to look at how can you better connect pharma through the healthcare systems in each individual country with the GPs and with the patients, and actually get a better understanding of the adherence. In other words, are the patients actually taking the drugs as prescribed, and are the results coming out as anticipated they would, based on those patients taking the drugs as prescribed. But yeah, so that's one small example. The other one to look at, I think, would be human to machine at the top, extreme mobile broadband. Not so much the virtual reality, but the augmented reality side. So there are a lot of applications where you need high capacity video, and you need connectivity, and you need it at a distance. or you need it within a confined space. So one of the things we did look at, we didn't actually do a direct discussion with JCB itself, but certainly one of the things that would be applicable, for instance, say to HS2 and the construction of HS2, is where you've got hundreds of machines that are digging up, moving materials around, crushing materials, putting new stuff in place, where each machine not only has a driver, but actually has one or two humans outside the vehicle to ensure that that machine doesn't interfere with another machine or doesn't run somebody over, etc., etc. It always is a challenge. Some of those challenges are being addressed today by removing the driver from the machine itself and putting the driver somewhere else, and then using remote connections, such as effectively it's like a UAV. The other approach is to light up the vehicle. So if you light up the vehicle with 3D cams all the way around it, and then an AI that quickly interprets the fact that if you swing the jib around on the crane, you're going to go hit something, then you can link that into the vehicle systems itself. That actually puts a halt to that move ahead of the driver actually seeing it, or somebody outside seeing it. So it's one of those areas that is being looked at the moment, and it's augmented reality, because not only would it work with the machine itself, but it would actually put the display in front of the driver as they're actually operating that piece of machine. So there are 2 or 3 mines out in the US now that are playing. They're not using 5G at the moment, but using a mix of IoT and 4G on private networks to do that already. And yeah, so there's just like some examples. I mean, there are many. There's lots of different discussions there. But again, I haven't got the slide in here, but there is a slide that says, could we do all of this without 5G? In a lot of cases, the answer is yes. But that's when you start, if you look at it purely from sort of the radio and the connectivity aspect. When you look at it from the next bit, though, which is the network slicing part and the edge computing part, there are some specific things that are going to happen in the core of the network and at the edge of the network that are quite interesting indeed. So we discussed briefly the concept of a network slice. So if you look at the left-hand side of the diagram at the top, so you've got use case specific slices, and you can have multiple of those slices. In reality, a network or an operator may only have, say, 5 or 6 of those. In other words, it's got a public safety slice, it's got a couple of manufacturing slices, it's got a public transport slice, etc. However, the slicing concept can be broken down. So you can actually move from not just a specific use case slice, but into something that's called sub-slicing or splices. And that allows you then to actually have an overall master slice. But when you deliver it to one customer, the sub-slices are slightly different to that of another customer. And that's purely about the SLAs that are being used and the contracted features that you might want to deliver.
Got a quick question on that, if it's okay. Sorry to
Sure.
jump in. So where you've got a use case specific slice, I presume that that's guaranteed bandwidth through the network, is it? And then the sub-slicing may be isolating from a visibility point of view, as in people on the pink sub-slice can't see what's going on the green one, but maybe they're all sharing the bandwidth that's allocated to a specific slice for the use case.
You could be. There's 2 or 3 different ways of looking at it. So, for instance, if you had a production line slice, you might actually have 2 sub slices underneath. One of the sub slices is the low bandwidth, low latency, massive connectivity of sensors off the production line. The second slice, sub slice, might be the high bandwidth video connection that you might want to deliver only if one of those sensors actually highlights a problem, for instance. Yeah. So do it that way.
Okay.
Yeah. There's a concept of highly dynamic slicing, and this is all about fast service creation and fast service delivery. The applications of that are questionable, but one theoretical application would be you've got a commercial network that not only supports commercial traffic, but also delivers a public safety component. So if you had a major incident somewhere, you might wish to use a dynamic slice to actually enable capacity and connectivity with a different set of characteristics in a given location. In other words, only in one part of the network versus the whole network. So that would be one way of doing that. The other part with slicing is the ability to integrate multiple bits of technology. So 5G is not just about the 5G radio. 5G from the core does have the ability, either directly or indirectly, through slicing or what some companies call a network operating system, the ability to actually interface and connect to devices through different types of technology. So you could actually integrate 4G, 5G, different types of IoT, LoRa, for instance, yeah. But it visible, as far as the application is concerned, it all looks like a 5G app. No? But underneath it, you've
does that mean that the segregation in 5G is using existing protocols that will then translate onto a private network and maintain the segregation or the bandwidth allocation?
It may or may not be a private network. It may well be just a straightforward single network, commercial network.
Okay.
Okay. So it depends on how you actually do the connectivity from the 5G slice and drop down then to the individual technologies that are underneath it. So there are a couple of companies like one of which is Zeta Networks, based over in Bristol. They have a slicing capability, but it looks more like a network operating system. So it's able to actually integrate all those bits underneath and present it up as a single slice. And then you can run multiple instances, each instance being another slice.
Peter, it's Phil. I'm just a bit aware of time. I was just thinking it might be worth, if that's all right.
Yeah, that's
and
fine.
obviously, we can trade people's contact details afterwards. So, Joe, if you've got any other questions, we can.
Sorry, Phil.
Yeah.
That's all right, man. No problem. No, it's good. It's good. It's good.
All right. So I'm going to do one more complex slide, and we're going to move back into some easier stuff. So I'm not really going to go into this, but sliced to abstraction. So yeah, this is where, yeah, if you sat there as a bunch of engineers and actually look at it, yeah, for sure you could have 20 odd slices. I think what's critical here though is how this all fits together. And there are 4 components on the right hand side. So at the bottom, we have this thing called a user plane and a control plane. So today we have a 4G network where the control and the data sit within the same plane. With 5G, then the aim is to actually split that out. Now 5G, as is delivered today, is called 5G non-standalone. In other words, it's a 5G radio sitting on top of a 4G core. So you still have the control plane and user plane in the same plane. When you go to 5G standalone, the control plane and user plane are separated out. So now you have the concept where a device at the edge, like your handset for instance, has a control plane interface back into the core of the network that is independent of anything that's in the middle. So effectively the network talks to you direct, or you talk to the network direct, which is different to what 4G is today. So if you remember back to the diagram, with 4G you talk to an individual base station, to a controller, before you get back to the network. With 5G, we remove that complexity. With 5G, there's a control plane which links your handset or your device into the core of the network. What that means is that if you then decide to do, say, 1 or 5 different things with that device, you can then manage the resource that's needed through the data plane, in this case, the user plane. Yeah? So that user plane is all of the data connections that you might need. What does that give you? It gives you the potential to do one thing, and that, or 2 things. One thing is to actually have the transmission network split in 2 parts. So you can have the high efficiency, high cost control plane segregated out from the low cost mass capacity data plane, which then brings in the ability to say that at a base station, you could actually break out the data and just dump it straight onto the internet. Why would you want to do that? Well, perhaps it's for something like edge computing or edge content availability. So for instance, if you were Netflix, you knew that there's three base stations in close proximity in the center of London, it would be easier for you to deliver a Netflix box and connect it directly to those 3 base stations. Now, to do that, you need that user plane, because the users will ask for something from the network, but it'll get delivered locally by that Netflix box, which basically means you're not tying up huge amounts of network capacity to deliver something that can be delivered locally. I'm going to leave it at that. It's worth half a day in itself as to whether where edge computing sits. Does it sit on the edge? Does it sit right on the very edge? Or does it sit somewhere else in the network? We referenced private networks earlier. I'm just going to touch on it quite quickly. There are certain parts of industry that work quite well with private networks. So a private network could take many different forms. It could be just a local instance of an EE network or a Vodafone network, but it's something that's been segregated off, or it could be a 100% private network with no external connectivity to 5G or anything else for that matter. So things such as ports, airports, manufacturing plants, process plants, power generation, hospitals, all those mass types of things have a lot of things that you might like to do more efficiently, and private networks might be one of the answers to do that. There is another approach called neutral host networks, which is basically where you have a single infrastructure and you deliver one or more mobile network operators services across that infrastructure. There is an overlap with private networks, but again, it's not something we're going to go into today. But bear in mind that in Germany, for instance, there's a huge amount of interest on private networks. So BMW, Audi, VW, etc., are all building their own private 5G networks. Siemens is doing it, Bosch is doing it. There is one at Hamburg port. If you look at, there are a lot of 4G private networks out there today. So Charles de Gaulle Airport, Brussels Airport, Amsterdam Airport, you are using private 4G networks to actually on their networks itself. Lufthansa has actually built its own private 5G network, and it's using it for engine maintenance on its aircraft fleet.
Just a quick question on that. How private is that? Are they actually reserving portions of spectrum solely for their own use?
They're requiring spectrum for their own use, yeah.
Well, okay.
You don't have to, but you can. You can actually say you can actually have a private network, which is just an instance off of an existing mobile network. But certainly the ones in Germany and some of the interesting ones in other countries are all using their own spectrum.
Okay.
Right. Somebody asked a question about 5G security. I don't intend to go anywhere near 5G security. Because it's the last time I looked, it was a 60-page document, and there are about 5 different documents, all of the same length, going through various aspects of security. There are a couple of things I will touch on, though, for sure. So in terms of 5G itself, and is 5G secure, there are no specific prescribed security requirements for 5G, and there are no new protocols that have been engineered from a security requirement. If you look at 5G itself, there are lots of things that 5G does different to 4G on a security basis. In other words, it's doing it so that vulnerabilities that were there in 4G, for instance, no longer are there in 5G. No? But from a security aspect, there's nothing specific as such within 5G to address security.
Peter, quick question on that one then. So is that because it's deemed to be not important, or just people haven't got around to it yet?
It's not so much as deemed it's not important. It's on the basis that if you and I were building a 5G network from scratch and we didn't have anything that was legacy, we'd go out, we'd buy a bunch of IT, well, we wouldn't buy it at all. We'd actually go and rent some space in the data center. You know? We'd spin up a couple of virtualized capabilities using Kubernetes or something like that, yeah, that we then build a software-defined network on top of that with NFV. So we build up a whole bunch of virtualized stuff all in software, and then we then hook a bunch of radios to it. So we could do that today. There is nothing in the 5G protocols to actually say this is the security you need to do. Yeah.
So does that mean then, I know you don't want to go into security too much, but does that mean then that there will be 5G networks where the cores are not encrypted?
They could well be, yeah. So
okay.
what I'm going to look at, so if you actually look at the picture at the top center there, what is very clear is that with 5G networks, there are so many more vulnerabilities that get exposed. Now, some of those are inherent from 4G, and they will get addressed in 5G and fixed in 5G. If you're looking at existing networks today, which are effectively 5G built on top of 4G, then effectively you've got a legacy network there. So your security is built around the legacy network, not built around that new 5G virtualized network that you want to do. Yeah. If you then look at it from a IT basis, so in other words, we're going to build a 5G network. We're not going to build it telecoms way. We're going to build it the IT way. Yeah. So OpenStack, etc., etc. Now, so we need to look at how do we make that network secure now, because 8/10 of that network is in software. Yeah, 2/10 of it is a bunch of radios hanging off the end.
But that would be the good news, because normally vulnerability management is an ongoing thing, and the fact that it's all in software means you can react to that and patch, rebuild, etc. as required.
Okay, right. Okay, all right. So so the one thing to look at is the bottom right-hand corner. Now, and that's trust. So from a 4G network, which has the user trusted to the network, but a bunch of services that there is no trust in, when you get to a 5G network, everything has to have an element of trust. So when you look at your 5G network, you have to look at it on the basis, what do we trust and what don't we trust? Yeah? So we can build things that we can trust. Then there's a whole bunch of stuff that we semi-trust. Then there's a whole bunch of stuff that we don't trust at all. So for yours, the cyber guys need to look at it on the basis, okay, this is the trusted bit. We make that 100% secure. This is the semi-trusted bit. So we need to understand what we do trust and what we don't trust, and then manage for that. And then there's the bit out there that we don't trust at all. So we need to manage for the bit that sits within that untrusted environment, build all the security that we need, and then we're happy. But none of that is in specific to 5G itself. So there's nothing new that's in 5G for that security. It's all about how you build your systems in your network. Okay, we'll leave it at that. Just on the quick, I'm going to scoot through on the timeline basis. So where we sit today is 2020. We've got 5G networks out there. They're all built around release 15. Release 16 was pretty much finished, but it got delayed by a few months because of some issues. So it's going to get signed off shortly, but there will be an impact certainly this year in terms of actually getting that out and getting it into software and then getting that into networks. Release 17 is the next major one, so that needs to be signed off early part of 2021 with availability in 2022. So what that means is that come 2023, release 17 will have hit most of the commercial networks that are out there today. So those networks have been upgraded. Release 17 has a lot of those clever things that we like network slicing, for instance. So you can do slicing today, but it won't really work until release 17. And not only that, release 17 is the first full version of 5G that can operate as in standalone mode. So it has all the core support in addition to the radios, such that it doesn't need a 4G network anymore. So that means a mobile operator can actually now run its 5G network in standalone mode and then have its 4G network sitting alongside. And there's a wonderful feature, which is is there today on the radio side, but will come along on the network side, which is called dual connectivity, which will mean that your new 5G handset will have two connections, one to the 5G side and one to the 4G side. As I say, it works in the radio today, but it doesn't work within the network itself.
Slightly scared to ask this question. Do you know when we'll get 5G capable iPhones?
This year.
For sure?
Supposed to be about September, October. Depends on the supply chains, though. Yes.
Yes, right.
Yeah. So now, as I understand, for 5G iPhones, they split off from Intel, and then had to fall back onto Qualcomm once they'd sorted out the lawsuits, etc., etc. And first iPhones will come out with Qualcomm chipsets. I'm assuming it's going to be an X60, X55, or an X60 chipset. So if you want to look up the Qualcomm X60, that hopefully will be in the iPhone.
Well, like you, I'd be looking forward to 80 meg on Southwestern Railway once all this coronavirus stuff is all over.
Yeah, absolutely.
Half a meg on Southwestern Rail would be nice.
I mean,
Peter, sorry, just a question. I mean, in terms of just for the broad audience here, you know, if things are coming down the line at a rate where sort of 2023 is looks like it's the sort of bulk of the rollout. I mean, is there anything we should be doing now to prepare, training skills wise? I know it's a very broad question. We're just trying to work out if there's anything we should be doing.
That's an interesting one. From the radio aspect, most probably not, but from the core network, definitely. Because when you guys start building applications and building services, as I mentioned earlier, most of the mobile operators don't have a real idea on what a service is, how to build a service, and how to deliver a service. So there's going to be a massive opportunity there. As I say, it will come out of the systems integrators. It will come out of a whole bunch of innovative SMEs that come up with clever new ideas, which is why government's been throwing money at the 5G testbeds. I'm going to skip a bunch of slides. We'll come back to the testbed bit in a minute, because there are some good competitions out there at the moment with lots of money behind it. So quickly, just from an operator perspective, the black dotted line is where we sit today. So we're very much in that initial deployment with Vodafone and EE over the next through 2021 to 2022. We should see 1,500 to 2,000 sites on each of their networks up and running. 3 has got a target of getting 6,000 sites fired up, but I think they've got some other challenges that they need to figure first before they can get that done. But basically, yeah, so we're in that initial deployment stage. We've gone past the trials. We know what it is. We've got handsets. Just on the handset side, no, let's come back to handsets in a second. But 2023 is that big inflection point where you'll see networks with greater than 40%, 50% coverage. But also more importantly, you'll see the standalone capability. So standalone capability means you can get a 5G handset. The control plane will exist. It'll typically use a low frequency like 700 megs or 800 megs hooked back into the network. And then when you try and do things on your handset, it will use whatever spectrum or frequencies it can find, whether that be 3.5, 2.5, 2.1, 1800, for instance. It will go figure that out, and it will get the resources and the capacity and the speeds and bandwidth it needs from the network, and it will do that without touching 4G. If there's no 5G, of course, it will fall back to 4G. If you can't get enough out of the 5G network, it will also leverage the 4G network. So my 5G handset will leverage the 4G and 5G today because it's still anchored onto 4G. But in the future, the handset will be anchored off of 5G, but it'll pick up on 4G if it needs it on that part. So let's get on to that one. Just quickly, for those who are going to ask the question, what about 6G? 6G community already exists. They had a big meeting last year. This year's happened last week. It was all, in fact, was it last week? No, it was this week, earlier this week. It was all done online. But there is a timeline there that for 2030, when 6G ought to exist and become a reality in that initial trial phase. And what are they going to put into 6G? At the moment, it's very much high-level things, but human-to-human, human-to-machine type comms versus what you do with a handset today. So it's slightly changed world. I haven't got into the what impact it'll have for the consumer yet, but certainly there's a whole bunch of guys working on it, and it's all driven out of Finland, interestingly enough. Right, we'll move from that one. Just on the spectrum side, today most of the 5G networks in Europe are using the 3.5 spectrum, so that's 3.4 to 3.8 on the diagram in the center there. Some of the countries have auctioned 700. Some of the countries have yet to auction 700. Legally, the mobile operators will be able to use the 700 spectrum from the end of this year, i.e. the end of 2020, and that's basically when all of the digital terrestrial TV switch off is finished.
Yeah, I was wondering about that, because I remember back in, I think 2014, they were talking about TV white space, hence this analog TV spectrum that's vacated, running at 470, and saying that that would be particularly suitable for sort of mid-band traffic that has to travel long distances to reach a base station.
Mm-hmm. No, I think TV white space is going to disappear.
Interesting.
Yeah. So the 700 band will come available at the end of this year. There's a couple of countries, Italy being one of those, where it will be 2022 before it becomes available. So by come 2021, we should have 700 available. We'll certainly have 3.5. Depending on the countries, you might want to use 2.6 or 2.3. All of those bands are going to be on handsets towards the end of this year, beginning of next year. Then there's the high band stuff, like the high capacity 26 gigahertz. At the moment, there are 2 countries that have auctioned 26 gig in Europe, but pretty much there is no real demand for it. We can do as much as we need using low band and mid band on 5G today. In other words, we're not doing that sufficiently high capacity that we need 26 gigahertz in the handsets, which is different to the US. So if you look at the US, Verizon's initial 5G network is on 28 gigahertz, AT&T's on 39 gigahertz. It gives them some amazing figures for bandwidths available at handsets, if and when you can find the base station stand next to it. It also gives you the other challenge that if you're in Phoenix, Arizona, say May time, when the temperatures come up, and you light up your 5G handset on 39 gigahertz on AT&T's network, it will work for about 5 minutes and shut itself down because it gets too hot. So there are some significant challenges on heat management when you're using those high frequency bands.
I remember being in Scottsdale once, which is near Phoenix, and they said if you haven't set off for your early morning walk by 6 a.m., don't bother because it's too hot.
Yeah, absolutely. But, so let's move on, conscious of time. Where we are at the moment, this is handsets and devices. The handset on the left is the OnePlus 7 Pro 5G from EE. That's the one I've got. It's, as a handset, it's blisteringly fast. It's like 8 gig of RAM, 256 gig of storage, 8 octa-core. And if you stick it on at home here, I've got a 330 meg fiber connection with Wi-Fi that runs up to 800 meg. If you do an update on Google for all your apps and so on, it's done in a few seconds. Amazing device. But there, if you look at it 2020, you'll see in the first half there's a whole tranche of devices coming out. So the Galaxy S20 is just hit in 3 different versions. Future versions of OnePlus, Oppo, the Huawei ones you won't see too much at the moment. There's Vivo, etc. All those handsets will be 5G capable. The only thing to really check out is to which frequency bands they support out of the box. Mine only supports 3.5, so in 2 years' time, I'm going to have to junk it and swap to something that'll do the other bands as well. If you're out and about and you're sad like me, you'll spend half your time looking at rooftops and what goes on them. So the bottom left-hand corner, you can see there's an existing 44R big panel antenna, and alongside it then is a 5G massive MIMO antenna. Likewise, on the right-hand side, again, you can see that massive MIMO antenna there. The one in the middle has got a mixture of both 8T, 8R, so that's 8 transmit, 8 receive 5G antennas, along with the massive MIMO antenna. So that's what you'll see pretty much being installed across the UK. And most of it's on rooftops at the moment. The reason being is if you look at the 5G antenna, it's sitting on its own piece of steel. It weighs 32 kilos. It's got a whole bunch of other boxes down on the rooftop itself. So if you have to put this up a tower, the maths at the moment say that 60% of the towers in the UK need strengthening in some way or other before you can stick 5G on them. So a bit of a challenge for the mobile operators. I put a map up here of EE and the cities and the towns that they're covering. Vodafone this week announced another 19 cities that they're going to have coverage in, the rest of it. So from a general basis, the 5G coverage that is going out there today is what you class as thin. So in other words, it's sufficient 5G in that if you've got a handset, the indicator will come up on screen and it will flip over to 5G and you'll get that additional capacity and you will enjoy it because there's no one else on it. But it is very much thin coverage. To get to that dense...
Quick question. You mentioned ports having things like private networks.
Yeah.
I live in Southampton, which is, I think, one of the biggest ports in the UK, maybe behind Felixstowe, and yet there's no dots around Southampton. How's that?
I don't know what it is with Southampton. It's a strange one. I don't know. I mean, it's like Guildford. Guildford now has 5G off of EE, but it's one pokey little base station on top of the BT exchange. It's absolutely abysmal. Waste of bloody time. So yeah, I don't know why. Must be a good reason for it.
Probably all the installers live in Portsmouth.
Something like that. Yeah, so the coverage that's going out there is thin. It's not that fat, deep coverage that you'll need. Two reasons for that. One is that the rest of the spectrum auctions have yet to happen in the UK. So once we get those out of the way this year, then hopefully at least 3 out of the 4 of the operators will have the additional spectrum that they need to compete with 3. 3 does actually have some grid sites at the moment. So the fastest I've seen on 3 is 1.8 gigabit on their Maidenheads and Reading sites. There's one up in London which is running about 1.6 gigabit. The most I've got out of EE is 653 megabit. And that's a combination of 5G and 4G. The other reason why the capacity and the bandwidth is still a way off of where we want it to be is fiber. So a lot of the towers still have microwave connections and they don't have that deep fiber that's going to be needed. And deep fiber means a minimum of 1 gig, but ideally you want a 10 gigabit connection on every tower. And if you think about it from base stations, there's 63,000 base stations at least in the UK. And each one of those needs a 10 gig fiber connection. So it's going to take a while for the MNOs to actually catch up with that. I'm going to skip this stuff. I'm happy to put out a PDF afterwards if you want to get it. Just quickly on DCMS. So there's a £200 million program. Phase 1 has now completed, apart from the Urban Connected Communities program, which is called West Midlands 5G. West Midlands 5G is hugely active, extremely well funded. They're doing calls for companies to actually come and engage with them. They're putting money on the table. So if you want to go play with 5G, you've got a sensible application, then West Midlands 5G is worth contacting. Phase 2, RCC and manufacturing, those competitions have just closed. The winners have been announced. So they've got to start building their networks in April of this year. Phase 3, the competition is literally just started last week, and the details and documents should be up on the website by the end of this week. There's 30 million available there to do something, and it's just called 5G Create. It doesn't have to be in the creative sector at all. So you can either engage through DCMS, or you can engage through Tech UK, through the Digital Catapult, the Connected Places Catapult, or there's an organization called UK 5G. So uk5g.org.uk. They have got a huge amount of resource on 5G. So well worth taking a look at them. And as I say, if you're working with companies or you want to get closer and more involved, there's a whole bunch of projects going on. From a private network capability, I know, for instance, that Basingstoke and Dean Borough Council will be going out to tender to build its own private 5G network next month. I did part of the funding application for that last year, and thankfully they were successful. There are some other 5G networks that have been built. So there's one in Camberley. They're trying to get hold of their money at the moment, but they've certainly got the technology available. As a summary, I'll leave you, when the slides go out, you can read this yourself, but I put a bunch of questions up there. And this is not a summary of what you've read. This is a summary in terms of what companies should think about if they think 5G is going to help them out. So in other words, where does the true value of 5G reside? Which 5G use case do you find compelling? What are the challenges in capturing value from 5G? And how are you addressing those? So this is all the things that the competition winners will have addressed in some way or other, so they can actually get funding out of DCMS to go build their 5G testbed. But it's certainly all be an interesting sort of 20 minutes, 30 minutes, just thinking through some of those and what the answers might be. As it might throw up something interesting, or might just mean that you don't want to do 5G at the moment because you can do all these things somewhere else. And that's it. As I say, there's the screenshot of my 634 megabits, 54 megabits down on AE, and I did that indoors in a conference center. So the 5G site was literally on top.
You could run a few Xboxes on that.
Sorry?
You could run a few Xboxes on that.
Yeah, you could certainly do that. And as I say, at the bottom left is where some of us are going to be focused in the next couple of years. So guys, taking a bit longer than I thought. My other half has been knocking on the office door saying dinner's ready. Hopefully that was useful. You understand a bit more.
Yeah.
Very interesting.
Yeah, Peter. I mean, yeah, on behalf of the guys, I mean, thank you very much. That's exactly what we wanted. It covered a lot of ground, and clearly, if anyone's got any questions about how this could work or anything specific, you've got Peter's details there, or by all means, get in touch with me, and I can forward things on. The next session is Smart Cities with Mr. Cooper, who's on the line. So that'll be one to look forward to, and he's bringing along some local colleagues who are going to talk about some local projects in that regard. So that'll be useful. I mean, if anyone got any questions or points they want to make? No. Should we all flick our videos on and make a little team photo before we all go and have our dinner? I think that's important, that sort of stuff. Hang on. Right. Come on then, everyone get the videos on. I'm going to take a screenshot and then you can all go and have your dinner.
He just wants to prove that everybody's still here, doesn't he?
Yeah, basically, yeah, and then no one's asleep. In fact, I don't know how to do it. Hold on, how do you? Oh, stupid thing. There's got to be a way of doing this. How do I? Oh, hold on.
You need to take Peter's presentation off, I think.
Okay.
So I stop sharing.
Perfect. There you go. Look at that. That's a thing of beauty. I can't even fit you all on the screen, I don't think. Oh no, a few people have dropped off. That's fine. Right. There you go. That's all right. In fact, everyone, give us 2 fingers.
Which way?
It's telling me if I enable the camera, I have to quit the meeting. Sorry, I can't switch it on.
Okay, we'll just...
Not letting me.
There you go. Brilliant. Well, look, thank you very much for coming, guys. Really good to see you all, albeit virtually. Hopefully next time we'll all be together in May. I'll keep you all posted via email. Like I said, if you've got any questions for Peter, by all means, do it via me or via Peter. You've got his details. And thank you very much for all your time. And Roland, your use of the virtual backgrounds is really quite impressive. In fact, I need to try and work out how to do that. Hold on. What virtual background options have we got?
I had a meeting on the top of the Gherkin last week, so I thought I'd take a picture and then now use it as the background. So it's cool.
I haven't got any. That's disappointing. Well, that's it. That's my objective for the next session. All right, guys, look, take it easy. Thank you for hanging on in there, and yeah, hopefully see you all in a few months.
Thank you.
Thank you.
Thank you.
Cool.
Bye.
Been real.
Thank you.
Bye.